So these notes are for integrated one. This is on our notes on exponential word problems and compound interest. So in example one, flu epidemic hits the local area, 30% increase in cases reported this week. Today, there were 100 cases reported to begin the annual flu season. If the rate continued, how many cases would be reported 4 weeks from now, 7 weeks from now? Write an equation for X weeks from now. So for all of these exponential word problems that are kind of dealing with geometric situations that we saw in our sequence chapter, what we want to remember is all of these are going to have the same format, where you have y equal some initial value a times some multiplier b to the power x. So again, I'll write it out in words. Y is equal to initial value times a multiplier to the power of usually time for a lot of these problems. Now, when we're dealing with percent increase or percent decrease, what is going to happen is when we have a 30% increase, we are going to take 100%. We are going to add or subtract depending if it's increase or decrease. It's increasing, so we're going to add 30%, which gives us 130% that we're finding every single time. And when we change that to a multiplier, we take this decimal, that would be after the 0, move it 2 places, and it becomes a 1.30, and that's going to be our multiplier. So when it is 4 weeks from now, I'm going to start with the initial value, and the initial value in this case is 100 cases. So I'm going to start with 100 cases. I am going to times it by the multiplier, which is 1.30 or just 1.3, raised to the power of time, in this case, 4 weeks. And then we're going to put that into our calculator. Right now I have this in Desmos here on the side. This is the scientific calculator Desmos, which is an option when you're on Desmos. This is going to be 100 times 1.3. Let me move my cursor here. And let me see if I can make this bold. Do they have a bold here? Okay. Times 1.3 raised to the power 4. And so our answer for this is, this is money. So actually, no, these are people. Sorry, I apologize. 285.61. So about 286 people. On the next one, we're going to, again, start with our initial value, 100, times it by our multiplier, 1.3. This time, raised to the power 7. And when I do that, let me just come over here and change that to a 7. And we get 627.49. So about 627 people if we keep it rounded down, or 628 if you weren't round up. So on this last one here, they want us to write an equation. So for our equation, we're going to have y equal our initial value, which is 100, times our multiplier, which is 1.3, raised to the power x, where x is the number of weeks, and that would be our equation. So on the next one, when we're doing the next one, this time we're going to have a percent decrease. So in this case, we are starting initially with $17,000 for a Mazda Miata. It is depreciating, which means it's decreasing by 22%. And we want to know each year, and we want to know how much it would be worth in 4 years, 10 years, and so forth. So when we're doing this, we're trying to find our multiplier. Since this is depreciating, we're going to start with 100%. We're going to minus 22% because we're losing 22%. And that means every time we're really trying to find 78%. So we're losing 22, but we have, okay, this is how much we have, 78%. So when I change that to a multiplier and I move the decimal 2 places backwards, it's after the 8, 1, 2, I get 0.78 is our multiplier, okay? So when we're setting this up, again, start with your initial value, 17,000, timesing it by our multiplier, which is, I'll put the 0 in front, 0.78. In this case, raise the power of 4 for 4 years. And we're going to put that into our calculator. So in this case, I'm going to have 17,000 times 0.78 raised to the power 4. And so that's going to be, this time this is money, $626,292 and 559. I'm going to push that up to 56 cents. On the next one, it's 10 years. So same idea, 17,000, our initial value, times our multiplier, 0.78 to the power 10. And when we put that into our calculator, so 17,000 times 0.78 raised to the power 10, the car now is only worth $1,417.08. Write an equation for the X years from now. So we're going to go Y equal, again, our initial value, which is 17,000, times our multiplier, which is 0.78, raised to the power X. And that's going to be our equation. So now on the next page, we're going to be dealing with compound interest. So when we're dealing with compound interest, you need to remember there's a difference between simple interest and compound interest. So when I'm dealing with simple interest, you get a percent of the original, the initial value. So you get a percent of initial value and each year you get that same amount. So this is arithmetic. You're adding the same amount each time. You don't get an increased amount. Okay, now we're dealing with compound interest, okay? And when we are dealing with compound interest, what we're doing for compound interest is you get interest on your interest. So you get the percent of the new value each year. So you get interest on your interest. And this one is geometric. So that means we're timesing. So in this situation, let me just kind of highlight some of the important information. Okay, you have a 6-year-old sister. Okay, she started with $100 from your grandfather. You tell her to put it in the bank. If the bank pays 12%, annual interest, how much will she get by her 18th birthday? Okay. So first thing, they're saying, okay, what if it is compounded? What if it is compounded annually? Okay. So in this case, it's compounded annually. So if that is the situation, what our multiplier is going to be is to figure that out. We are going to be taking 100% plus 12%, which is going to be 112%. So our multiplier is going to be 1.12. That is our multiplier. Okay. Now we want to know how much she has on her 18th birthday. So for that, when we're trying to figure out how much she has on her 18th birthday, we are going to be taking each time 18 years minus 6. So she's going to have this for 12 years. Okay, so every one of these she's going to have for 12 years because 18 minus 6. So we're going to start with the initial value, which is $100. We're going to times it by the multiplier, which is 1.12. And we're going to raise it to the power 12 because she's going to have it for 12 years. And we're going to put this into our calculator. So when we do that, we're going to have 100 times 1.112 raised to the power 12. So she's going to have $389.59. Well, the 7 is going to push it up to a 60. That's how much money she's going to have. Now, in the next one, she gets it semi-annually. And so she gets it semi-annually. What that means is she gets it twice a year. Okay. So she's going to get it twice a year. Now she doesn't get the 12% because each one of these is still 12% annual interest, but she doesn't get that 12% twice a year. She gets 12% split into 12 equal pieces. So what we're going to do is we're going to take our 12%. We're going to divide it by 2, and she's going to get 6% twice a year. So that means that her multiplier, is going to be 1.0. Well, so it's going to be 100% plus 6%, which is 106%, or 0.06 as a multiplier. So remember, in this, she started with $100. We are multiplying it by 1.06. Now, this is where you need to be careful. She's getting it twice a year for 12 years. Twice a year for 12 years. Okay. So she really gets this interest 24 times within those 12 years. So I'm going to change this to 100 times 1.06 raised to the power 24, 2 times a year for 12 years. So she gets interest 24 times. And then this answer is going to be $404.89. So you see, having the 12% split to two increments, 6% each half of the year, gave her more money. Okay, so in the next one, it is going to be quarterly. Okay, each of these is still the $100. It's still 12% annual interest, but this time it is quarterly, which means 4 times a year. 4 times a year. So we're going to take the 12%. We're going to divide it by 4 and get 3% each quarter. So our multiplier is going to be 100% plus 3%, which is going to be 103%. So 1.03. So we're going to start with our $100 times our multiplier, which is 1.03. Now remember, this is quarterly, so it means she's going to get this 4 times a year for 12 years. So basically 48 times she's going to get this money. So when I do this, it's going to be 100 times 1.03 raised to the power 4 times 12 or 48. So again, she's going to get a little bit more money this time, $413, and I'm going to round it to 23 cents. That is going to be her amount. Now, on the last one, she's going to get it 12 times a year. 12 times a year. So she's going to get the 12%, 12 times a year, which is going to give her 1% each month. So her multiplier is going to be 100% plus 1%, which is 101%, or 1.01. That's going to be her multiplier. So we're going to start with her $100 times 1.01. She's going to get this 12 times a year for 12 years. So that's going to give her 144 times she's going to get the interest. So 100 times 1.01 raised to the power 12 times 12. Now, if you're going to, just a quick note, if you're going to do this on Desmos and raise it to the 12 times 12, you have to be careful. You can, but when you do 12 and you do times, it's going to drop down. So if you wanted that whole thing in a exponent, you go parenthesis and then do 12 times 12. So anytime you have something that's multiplying or adding or something like that in your exponent, you want to be careful, okay? And put parentheses, otherwise it drops down. Or we can put in the 144. So we end up with $419.06. Okay, now the last set of problems we're going to be doing on the next page is half-life. And a half-life is how long it takes something to become half as much. Okay, so half-life is how long it takes something to become half as much. So in this case, we're dealing with a radioactive isotope, undergoes decay. It does so at a fixed rate. The time it takes for half of it to decay is called its half-life. So a particular substance has a half-life of 10 years. This is just this problem. Not all half-lives have a half-life. I mean, not all substances have a half-life of 10 years. So this one has a half-life of 10 years. You start with 100 grams. You have how much left after 60 years? So if you're doing this, we're going to be starting with, whoops, I'm still in highlight. We're going to be starting with 100. And think about how many half-lives you've had. So if it's every 10 years, that means you've had 6 half-lives. So in this situation, when you're dealing with a half-life, your multiplier is always 1/2, or I'm going to write it as 0.5. And then in this case, since we've had 6 half-lives, I'm going to raise it to the power 6. Not 60, because every 10 years you take half. Every 10 years you take half. So we would do that 6 times. And so when we put this into our calculator, we're going to get 100 times 0.5 raised to the power 6. And so we have 1.5625 grams left over after 60 years. So now the next one is going to be 20 years. So if it's 20 years, how many half-lives have we had? We've had 2 half-lives. So in this case, we're going to start with 100. We're going to times it again by 1/2 or 0.5, raised to the power 2. And so if I take half, that's 50, and half against 25. So this one we can kind of do in our head, or you can put it in the calculator. So we're going to have 25 grams. Now those ones are nice because you can think about every 10 years, because these are both 10, 20, 30, 40, 50, 60. Now, what about one that's not quite like that? So if it's 55, you have more than 5, but less than 6. So really, what are we doing? We're taking 55 and we're dividing it out by how long a half-life is. And that's going to give us 5.5 for our half-lives. Okay. So I am going to take 100 times 0.5 raised to the power 5.5. So let me change this exponent up here to 5.5, and we end up with about, so I'm going to round this one, 2.21 grams. Now, basically what's happening each time when we're doing this is we're going to take how many years, we're going to divide it by 10. So this here is number of years. This is length of half-life. And that's going to be how we got the 5.5, the 2, the 6. Okay. So when we're writing an equation for this, we're going to get y equal our initial value that we start with is 100. Every time we're doing half-life problems, you're always multiplying it by 1/2 or 0.5. And this is going to be raised to X number of years over 10. That is our equation. So for a half-life problem, okay, in general, you're going to go y is equal to your initial value. Let me do it. Let me kind of color code it. Okay, so y is equal to your initial value, whatever your initial value is, times our multiplier, and our multiplier is always 1/2 or 0.5. Okay, but I'm just going to write 1/2 there so everyone sees it as a 1/2. Raised to the power x over half-life. And that is going to be your equation every time you're doing a half-life problem. So these were our notes. We did submit them for points. So if you're absent, you want to submit them.